Okay, so 5.5 is graph of inverse functions and increasing and decreasing. So we're going to be talking about graphing the inverses and finding the equation of the inverse like we did on Friday. But also then we're going to talk about the domain, the range, and increasing and decreasing of your functions. So we're going to start by just looking at the original function. G of x equals negative x squared plus 5. We are going to graph that. So we need to find the vertex. Okay, the vertex here is 0 for x and 5 for y. Since there's no parentheses here, it's like a 0 inside the parentheses. And then the plus the 5 is the k value. So that's the y value. So we're going to graph where x is 0 and y is 5 right here. Then our a value is the number in front of the x squared. So our a value is negative 1. And then to graph that, we'd go a over 1, then 3a over 1, then 5a over 1. So we can go down 1 to the right 1, down 1 to the left 1, then down 3 to the right 1, down 3 to the left 1, then down 1, 2, 3, 4, 5 to the right 1, down 1, 2, 3, 4, 5 to the left 1. And this is my beautiful parabola. Any questions over that? Okay, then we're going to describe that function. Okay, so it is a parabola. It has a maximum value at 0, 5. Its y-intercept is at 0, 5 as well. So the vertex is the y-intercept. The x-intercepts I can't really tell because I'd have to estimate those. So I'm not going to talk about the x-intercepts really. If it was on like 2, 0, then I would talk about it, but I don't really know. Any questions? Anything else we can talk about the function itself? Okay, now increasing is going to be written in interval notation, increasing and decreasing. So if you think of yourself as a car, we're starting from the left-hand side, and we're driving. Would my car be increasing as I'm going this way, coming from the negative numbers? Yes, I am increasing. So from all the way here to about here is where I'm increasing. And increasing is all about the x values. So it's from negative infinity. At what point do I stop increasing? At 0 for x. These are always the x values. Now, when I'm decreasing now, I start decreasing at 0 for x again. So again, as I get here, now all of a sudden, I am starting to decrease, go down. So that is to positive infinity. Because it will continue going on and on forever. Any questions over that? We're good? Okay, domain. We're going to write this in interval notation. We're used to writing it with inequalities, like x is greater than 5 or -5 is less than x is less than 6. But we're going to talk about this in interval notation now, because as you go on to pre-cal, they'll use interval notation more often. Okay, so the domain again is my x values. So I look at my parabola. How far to the left will my parabola go? If it keeps going down forever. Yeah? It'll go to negative infinity. So domain is from negative infinity. How far to the right will my parabola go? Very good. It will go on forever. It will go to positive infinity. So you can write like this in interval notation, or you can say all real numbers. Okay. Either one. So this or this. I think on a test, we're going to be more likely to write that. The all real numbers. But no both. Okay, the range now is a little different. Range, again, we're always going to start with the lowest point. How far down will my parabola go? Forever down, so it's my range is starts at negative infinity. What is the highest point it will go? 5. It won't go anywhere above 5. Since it can equal 5, right? Can it equal 5? Yes, that'll be the vertex. I put a bracket. Negative infinity is not really a number or a place I can be. I get closer and closer and closer to forever, right? Infinity is basically forever. So I'm never going to equal infinity. That's why I have just the parenthesis. Brackets mean equal, so I can equal the number 5. So that's why I use a bracket. Any questions? Now, because on increasing and decreasing, it's a little different. I put a parenthesis on the 0. Okay. The 0 is not, I'm not increasing at 0, and I'm not decreasing at 0. At 0, I'm changing directions. So I don't put a bracket on either of those. With domain and range, I will put a bracket. Does that make sense? Any questions? Yes? No, because again, well, if it was for the increasing and decreasing, I would not. Increasing and decreasing, I'm not going to use brackets, because at the point that I reach, so for this one, it was at 0 for x. At 0, I'm not increasing or decreasing anymore. So that will never equal that to increase or equal that to decrease. At that point, I'm changing directions. Okay. Any questions over that? Okay. So that's all my information for g of x. Now we're going to deal with the inverse of g of x. So here's my original equation. Remember, to find the inverse, I replace the x and y. So I'm going to get x equals negative y squared plus 5. So the x and y switch places, and then I solve for y. So I want to get the y by itself. So I'm going to subtract 5 from both sides. That's going to give me x minus 5 equals negative y squared. Now I want to get rid of the negative. So I'm going to divide by -1. That means x divided by -1 is -x, and -5 divided by -1 is a +5 equals y squared. Okay, now what would I do? Square root. And that gives me y equals plus or minus the square root of -x plus 5. Any questions over that? Now, we haven't learned how to graph radicals. You will learn how to do that next year in Math 3. So we're not going to try and graph that. We're going to take our ordered pairs and graph the inverse of these ordered pairs. So my x and my y. So the first one that's going to be easy is the vertex. Remember, I switched the x and y. So my vertex on my inverse is going to be 5 and 0. So I'm going to go where x is 5 and y is 0. Then my next point, I'm going to take from right here. This is 1 and 4. So the inverse of that is going to be 4 and 1. I'm going to do the same thing on this point here. This is -1 and 4. So I'm going to graph the inverse of that point, which is 4 and -1. Then I'm going to graph this point of 2 and 1. My inverse will be 1 and 2. And then finally this point. This is -2 and 1. Oopsie. -2 and 1. So my inverse is going to be 1 and -2. Sorry. So that's going to be down here. So this is going to be my inverse graph. Any questions over that? Okay, so we talked about this on Friday. This is a sideways parabola. So it's still, my function to describe it is still a parabola. Okay, the vertex is 5, 0 now. Is my vertex a maximum or a minimum point when it faces sideways? Maximum is the highest point or the lowest point. Okay, this doesn't have a highest point. It's going to go on forever. And it's going to go down forever as well, so it doesn't have the lowest point either. Okay, so this doesn't have a max and min. Is this a function? You guys remember the vertical line test? If I take a vertical line, yes. And if I hit my graph at any 2 points during that vertical line test, then it's not a function. Because the definition of a function is for every x value, there's exactly one y value. And in this case, when x is 4, y is 1 and -1. So this is not a function. So we also talked about whenever we have a plus or minus the square root, that would not be a function. Plus or minus the square root means it's not a function. So you don't have to even graph that to know. Okay. Any questions? Okay. Do we have a y-intercept here? I can't really tell what the y-intercepts are, but I can see that the x-intercept is now 5, 0. The x-intercept now is at 5. And over here, the y-intercept was at 5. Any questions? Okay, also, we can't really talk about increasing and decreasing when we have a sideways parabola. This is going to be increasing and decreasing the whole time, right? So this will go up forever, so that's an increase, and this will go down forever, so that's a decrease. So we don't talk about that because it's doing both at the same time. Any questions? Okay. So that's why we don't have the increase and decrease section there. Okay, the domain. Domain, again, is your x values. So let's look at the x values. How far to the left will this graph go? Forever. Yes. So the domain will be at negative infinity. It will never equal negative infinity, so it's a parenthesis. Okay, how far to the right will it go? 5. Okay. So 5 is the biggest it will get. And can it equal 5? Yes, so we put a bracket. Any questions? Okay, the range. Range is the y values. So how far up will this go? And how far down will this go? It's going to keep going, right? Not just stop at 2, because it will go to negative 3, then it will hit negative 4 eventually, then it'll get negative 5, and it'll keep going forever. Okay. So the range is all real numbers. Or negative infinity to positive infinity, however you want to write that. Any questions? We're good? Okay. Yes. Okay. Okay. Watch the rest of the video. Okay, describe the function. So now we're going to graph this linear equation. This function is linear. So I have my slope and my y-intercept that I'm going to graph. So I'm going to get at negative 4. And then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1. Make this as straight as possible. Okay, so this function is linear. My x-intercept. Class, where does it cross the x-axis? At 2. So it's 2, 0. And my y-intercept is at 0, negative 4. Any questions over that? Now, linear equations are a little bit different because they don't increase and decrease. They do one or the other. So in this case, as I'm moving from my left to my right, Is my graph increasing or decreasing? Increasing. So we say it's increasing from negative infinity to positive infinity because it's always increasing. It won't decrease. Okay, so that's all linear functions. They will either increase or decrease. They won't do both like a parabola. Okay, the domain. How far to the left will it go? Forever to the negative, right? Okay, so the domain will go to negative infinity, and how far to the right? Positive infinity, which again is all real numbers. The range, how far up and down will it go? Infinity, right? So again, this is negative infinity to positive infinity, or all real numbers. Any questions over that? Okay, now my inverse. So to write the inverse, again, I'm going to take my original equation and replace the x and y. So I'm going to get x equals 2y minus 4. And then I'm going to solve for y. Jada, what should I do first? Add 4 to both sides. So I'm going to get x plus 4 equals 2y. Selena, what should I do next? Divide by 2. Those will cancel out. And I'll get y equals, I'm going to actually divide this. So this is like a 1 in front. So it becomes 1/2 x. And then 4 divided by 2 is plus 2. So this is my inverse. Is that inverse equation, is that a function or not a function? Are we unsure since nobody's asking? Who thinks it's a function? You guys are sleepy today. Okay, who thinks it's not a function? Raise your hand. Who's just really not sure? Okay, good. Okay. Is this what shape is this if I graphed it? It's a line. All linear equations are functions except for when it says x equals. Okay, this is a linear function with y equals something. It's a function. Okay, if you're not sure, then you could graph it and see there. So we need my slope and my y-intercept. So I'm going to get 2. My slope is 1/2, or my rate of change is 1/2. So I'm going to go up 1 and over 2, up 1 over 2, down 1 over 2, down 1 left 2. I'm going to graph this. And that's my beautiful line. Like we said, it was a function. What did we say over here? It's linear. Still linear. My x-intercept is at -4, 0. And what about my y-intercept? 0, 2. My slope here is 1/2. Let's go back over here to my original. My slope here was 2. Now is my inverse function, is that increasing or decreasing? It's still increasing. Okay, as I'm going from left, I go up. So that's increasing. And again, it's not going to decrease then. And this will always be the case. If you have a linear function, its inverse is going to do the same thing. If its function is increasing, then its inverse will be increasing. If the function is decreasing, then its inverse will be decreasing. The domain, I'm still going to be able to go left and right forever, so that is all real numbers. Or negative infinity to positive infinity. The range too, I'll still be forever be able to go up and down. So the range is all real numbers. As well. Any questions over that? Okay, let's compare. I'm going to try and get this all together. Oh, it's going to be too hard to read under there. Okay, let's look at this one. What similarities do we see between the function and its inverse? Yep.
Same shape.
Very good. It will have the same shape. Is that true for linear functions as well? Yeah, linear functions are going to have the same shape. If it's linear, when I have the inverse, it's linear. Okay, here for the quadratic, it was a parabola. The inverse was also a parabola. Just turned on its side. What other things do we notice? Yep.
The A values are the same.
The A values are the same?
Yeah. Like it's going up by 1, then it goes by 3.
Yes, 1, 3, 5. Very true. The A values, or kind of like the rate of change. The patterned rate will be the same. Yep. Okay, how are the domain and ranges related? Let's look at that. Yep.
All of them have some sort of infinity in them.
Yes, that's true. And most domain and ranges will have at least one infinity in it. But more specifically, one of them has a bracket. Yes, true. Do any of them match exactly? Yeah.
Both domains have a negative.
Okay. Well, domain will always have a negative and a positive. Well, I shouldn't say always. Most of the time we'll have like a negative infinity to a number that's probably positive. Sometimes it gets say negative though. That's true. So I shouldn't say that. Yeah.
So basically, the domain is to switch to the range for the other one. And
Yes. So notice that the domain of my original function will now become the range of my inverse. The range of my original function will now become the domain of my inverse, which is completely what the definition of an inverse is. The definition is that the x and the y values switch places. So the domain is my x values. When I have my inverse, it's going to switch to the y values. Does that make sense? Okay, so if you can find the domain and range of your original, it's easy just to switch them to find the domain and range of your inverse. Okay, and that's the same thing with the linear. You just don't really notice as well because everything's all real numbers. Make sense? Any questions over that? Okay, next one. Now I gave you the graph instead of the equation of my original function. So we're going to write the equation first. Here's the equation in vertex form of a quadratic. We want to find the vertex. And my vertex here is 3 and then negative 3. And then we want to find the a value. And remember that a value is that first step. How far up did I have to go? Very good. I went over 1 and up 2, so my a value is 2. Any questions over that? So then I plug it into the equation. F of x equals my a value of 2 times x minus 3 squared, and then minus 3. Remember, this one just comes down, and this one changes signs. Just like in our absolute values that we talked about, inside the absolute values, when you take it out, it changes signs. Same with quadratics. When we are putting it in, we have to change the sign. Taking out or putting it into the equation will change its sign. Any questions? Okay, let's describe it. What shape is this, class? Parabola. Is the vertex a maximum or a minimum here? Minimum. At 3, negative 3. I don't really know what the x-intercepts are. I'd have to estimate those. And I can't see the y-intercept either, so I'm not going to really write any of that down. So that's as much. I could say the a value is 2. So that's a stretch. The increasing and decreasing. So let's go from there. Okay, so as I move from my left, what am I doing? Increasing or decreasing? I'm going down, so that's a decrease. So as I'm going this way on my graph, I'm going to be decreasing. So negative infinity. At what point will I stop decreasing? Going down. At 3. And it's always the x value. And this can be a bracket because it can equal 3. That's what the bracket means. It means it can equal 3. Oh, wait. No. I'm thinking domain all of a sudden. Is it increasing at 3? Right? At 3, it's not going to equal 3. As it's at 3, it's not increasing. Only on domain and range am I going to use my brackets. Sorry, guys. So this one needs a parenthesis. Because at 3, it's not increasing, it's changing directions. Any questions over that? Okay, increasing. So now, after I hit 3, Now I'm going to change directions, and now I'm going to start increasing as I'm moving from left to right. So this is going to be at 3. I'm going to start at 3 now. And then I'm going to go to positive infinity, forever increasing. And again, I don't have brackets here because at 3, I am not decreasing or increasing. Any questions? Okay, the most difficult is you guys are going to probably try and use the y values in this. So make sure you're always looking at the x values. That's a common mistake. Any questions? Okay, domain. How far left and right will my graph go? Gabriel, what will be the domain of this function? How far to the left will I go? Okay, am I going to -3? Right, does it stop at -3? This will forever go up this way, right? So how negative am I going to go? Infinity. So I'm going to have you at -infinity. And then how far positive will I go? To infinity, to positive infinity. Okay. Then we want to deal with our range are our y values again. Gavin, how far down will I go? What's the lowest I can go? -3, okay? Can I equal -3? Yes, in this case I can, because I'm just finding the lowest point. And my lowest point is exactly -3. It's not close to -3, it's exactly -3, so I need the bracket to show that I can equal it. And then Gavin, how far up will it go? Positive infinity. Any questions over that? Okay. Now for D, we want to take the original function and find the inverse. So I'm going to replace the x and y with my equation that I wrote here. So it's going to be 2 times x, not x, y now. Y minus 3 squared minus 3. Okay, I'm going to solve for y. Oopsie. No, what happened there? There we go. Okay, Ramiz, what am I going to do first to solve this? We're solving right here. How do I get that y by itself? Mm-hmm. Add 3 to both sides. Oh my gosh. So that's going to give me x plus 3 equals 2 times y minus 3 squared. Okay, this is the step you guys struggle with. You got to get rid of the 2 next. So you have to divide by 2 first. So that's going to give me x plus 3 divided by 2 equals, these cancel out, y minus 3, the whole thing squared. Now what should I do? Square root square root. So this is going to give me plus or minus the square root of x plus 3, the whole, all over 2. And it equals y minus 3. Okay, now what? Add 3 to both sides. So I'm going to get this fun equation. Y equals plus or minus the square root of x plus 3 over 2. And then outside the radical is a plus 3. And that's my fun equation. Any questions over that? Okay, now we want to graph that. I have no clue how to do this, and you won't do that until math 3. So we're just going to do the order pairs like we did before. So I have my vertex of 3, negative 3. So I'm going to switch those and get x is negative 3 and y is 3. Then we go to the next point that they have, which is 4 for x and negative 1 for y. So I'm going to have negative 1 and 4. So I'm going to go where x is negative 1 and y is 4. Then my next point will be over here at 2 for x and negative 1. So I'm going to have negative 1 and 2. So that'll be my beautiful parabola. Any questions over that? Okay, what's the shape here? Okay, this is a parabola. Is this a function? Not a function. It has a vertex at negative 3 and 3. Okay, this doesn't increase or decrease either because it's going to be doing both the whole time, basically. So we don't talk about increasing and decreasing on not functions. Then the domain. The domain should match the range of my original. So let's just check that. They should be matching though. The domain, the smallest it's going to be is at negative 3. And it can equal the negative 3 for the domain. How far to the right will it go? To positive infinity, which is what this should be. And they do match, so we did a good job. The range is up and down. So how far up and how far down should this go? Okay. Negative infinity, it's going to go up forever, or sorry, down forever, and it's also going to go up forever. Okay, or again, we could say all real numbers. How are we doing? I can add another page if you want me to.
Please no. No.
More examples, Johnny? Oh, good. Okay. I know, more examples of this. Okay. So now the last way I'm going to give you the function is in ordered pairs. Okay, so we gave it to you as an equation. We gave it to you as a graph, and now we're going to give it to you as ordered pairs. So you're just going to graph these ordered pairs. Yes. So I'm going to graph -4 and -1. So I'm going to go where x is -4 and y is -1. Then I'm going to graph -2, 0. I'm going to go where x is -2 and y is 0. Then I'm going to graph 1, 0. Sorry, 0, 1. 0 and then 1. Then I'm going to graph 2, 2. Then I'm going to graph 4, 3. And then this is my wonderful graph. Ladies. Okay, now that we've graphed this, what type of function is this? It's linear. Oh, good, linear. Okay, we need to find the slope and the y-intercept. So the y-intercept here is at 1. The slope is up 1 and over 2. So it's 1 over 2. Rise of a run. So my equation, h of x equals mx plus b. We're just going to plug it in. H of x equals 1/2 x and then plus 1. Any questions? This one they had h of x, so I put h of x. If you put a y, it's okay, but we're going to do what the notes say, h of x. Okay, we want to talk about the x-intercepts. The x-intercept is at -2. And the y-intercept is at 0, 1. Okay, is this graph increasing or is it decreasing? Okay, as I'm coming from the left, my numbers are getting bigger, my y values are getting bigger. So that would be an increase. It is not decreasing. Also, you can tell if my slope is positive, that's an increase. If my slope is negative, that would be a decreasing. So it is always increasing. So from -infinity to positive infinity is where it's increasing. Any questions over that? The domain is how far to the left and how far to the right I will go. Ethan Olson. Are you okay? How far to the left and right will this grow? How far, Ethan, to the left will it go and how far to the right will it go? Domain, infinity. So this is all real numbers. -infinity to positive infinity, however you want to write it. Then Celeste, how far up and down the range? How far up and down will I go? Yep. So it's all real numbers or -infinity to positive infinity. Any questions over that? Okay, so now we're going to graph the inverse. So remember your inverse of ordered pairs, the x and y values just switch places. So my y values become my x values. And my x values become my y values. So that's going to give me -4, -2, 0, 2, and 4. Any questions over that? Okay, so let's graph that. So I'm going to graph where x is -1 and y is -4. I'm going to graph where x is 0 and y is -2. I'm going to graph where x is 1 and y is 0. I'm going to graph where x is 2 and y is 2, 3, and 4. Any questions over that? We're all good? Okay. And then we can write the equation. Again, it's just going to be the inverse of x should equal mx plus b. So our slope should be up 2 now and over 1. So it's 2 over 1, which is just 2. And our y-intercept now is at -2. Any questions over that? So we're going to get the inverse of h of x equals 2x and then -2. Any questions? We're all good? Okay, now we're going to describe that function. Is it linear, class? Linear. My x and y intercepts now switch places. So my x-intercept is now at 1, 0. And my y-intercept is now at 0, -2. My slope, if you notice, is the reciprocal of each other. Slope here is 1/2. Slope here is 2. Okay. Okay, is this still increasing or is it decreasing now? Okay, as I come from the left, my y values now are going up. So this is not decreasing, it is still increasing forever. And my domain and range are both still all real numbers. Or -infinity to +infinity. Okay, let's start on some homework because there's a lot of it, right? Pause.